Assalamu alaikum, students. Students, in today's lecture, we are going to study entropy, right? That is the third topic of chemistry. In entropy, what is entropy? What is its symbol, its unit? You can see this on the screen. Entropy symbol is S, and entropy is the measure of disorder. Entropy is the number of possible arrangement of particles. See, you can see this on the screen. It is the number of possible arrangements of the particle and their energy in a given system. Number of possible arrangements. More the possibilities of the arrangement, more is the chances of disorders. If there are two places, less disorder. Three places where you can put the particles, more chances of disorder. See, if you see this example, this is jar A, this is jar B. So there are two positions, two places, but three particles. Right? If I remove this partition, all the three in jar A, and second possibility, all the three in jar B, one in A and 2, 3 in B, or 2, 3 in A and 1 in B. Next, 2 in A and 3, 1 in B. But what is the other possibility? 3, 1 in A and 2 in B. Now, 3 in A and 1, 2 in B, or 1, 2 in A and 3 in B. Look, there are 1, 2, 3, 4, 5, 6, 7, 8 possible arrangements. And when you arrange the particle, this is also the arrangement of the energy. When the particle disperses, the energy disperses because the particle contains energy. And it can be linked to exothermic, endothermic, but that would be then too much detail, which is not the requirement. You are just supposed to know that more the number of particles or more the possibilities of the arrangement, more the chances of dispersion of the particle and the dispersion of the energy. More dispersion, more randomness, more disorder, more entropy. Right? The symbol of the entropy is what? S. The unit is joules per Kelvin per mole. If you forget the unit of entropy, there is a trick. Like on the last page of your paper, the constants are given, the R value, the standard condition of temperature, pressure for the volume, the Avogadro's, all the constants are given on the last page of the paper before periodic table. If you see the unit of the R is 8.31, you know what is the unit of R? Joules per Kelvin per mole. Exactly the same is the unit of the entropy. And most of the time they ask in the paper. But okay, I'm not going to link the R with the entropy. The entropy is what? The number of possible arrangement. More the ways of arranging the energy in a molecule, more the ways of arranging the molecules in a system, more is entropy. Now, entropy is the measure of disorders, measure of randomness of particle, measure the randomness of the energy. Now, entropy depends on what? Definitely on physical state. If we compare the entropy, okay, before going to comparison, see, if you have p orbital, look, if you have p orbital, in every p orbital, 2 electrons can be accommodated to. Now, both the particles here, both the particles in the other loop, or the red is here, the blue is this way, the blue here, and so how many, like there are 2 electrons and there are 2 positions, 2 lobes, right? So how much? 4 possible. More the ways of arranging electron, more is entropy. Possibilities of 2 electron in one p orbital with 2 lobes. Right? Now, we are going to compare entropy. Compare entropy. When we compare entropy, the first thing, entropy of gas is more than liquid, so obvious. The entropy of the gas would be more, the disorder in gas would be more. Disorder in gas would be more than in liquid. Why? Because the movement is more random. Now, next, if the physical states are same, look, first criteria is what? Physical state. But if the physical states are same, then the particles with more number of atoms. If the physical state and atoms are same, then the one with more electron. If electrons are same, then check the proton. Look, look. Chlorine is gas, more entropy than liquid, than solid, agree? Now, if you see, these two are solids, but this one has more atoms. These two are solids, but this one have more atoms, more chances of disorders. The arrangement of the atom, the arrangement of the electron inside the atoms. See? In this case, gas, liquid and solid. So gas has more. Second, if both are solid, then count the atoms. Both are gases. See? 3 atoms and 2 atoms, more entropy. Now, next, if the physical states are same, the number of atoms are same, then the one with more electron, 12 plus 8, 20 plus 8, more electron. See, carbon dioxide and SO2. 1, 2, 3 atoms, 1, 2, 3 atoms, physical state, but electrons are less, electrons are more, disorder is more. If you see, potassium ion, chloride ions, both are one particle, both are gases, both have 18 electrons are same. Now what is the deciding factor? Proton. For the same electron, the one which have more proton, more hold on the electron, the particles are not that freely moving, the protons are more, the disorder is less. Right? Next, we know that when we compare entropy depends on physical state. If physical states are same, check the atoms. If the atoms are even same, check the electron. If electrons are same, check the proton. At the same time, we also know that entropy depends on temperature. When the temperature increase, kinetic energy increase the particles. The movement of the particle also more, the disorder will be more. Right? Entropy shows a sharp rise at melting and boiling point. Why? Because at melting and at boiling, there is a change in the physical state. Look, in question, be careful about melting and boiling point. Why? Suppose this is a solid. This is 0 Kelvin. You know, it's 0 Kelvin. We say at 0 Kelvin, the movement of particles cease. It what? Cease. No movement. High disorder. Highly ordered. But we can't say that disorder is 0. We can assume, look, I'm going to explain this graph on a separate page. Suppose this is entropy, and this is what? Temperature on Kelvin scale. Now, if I have, suppose I have H2O. You know, H2O is solid at 0 Kelvin, right? 0 Kelvin means minus 0 Kelvin. I think I should switch it to this place. H2O at 0 Kelvin at minus 273 degrees Celsius. Definitely it is solid. It is highly ordered. But I can't say that this order is 0. We can assume that its entropy is 0. So it's 0 Kelvin, the entropy is 0. Now, when you are increasing temperature, the vibration increase, vibration increase, disorder increase, and at 273 Kelvin, which is 0 degrees Celsius, which is the melting point. It was solid, its vibration increased, but now the solid will start melting. Melted the whole water, the whole ice, whatever I was taking at that time. You were taking at that time, it will melt. After melting, like the solid is turning into liquid, the particles are changing their motion movement from vibration to sliding, rotation. And when it is liquid, the particles are sliding over each other. More temperature, more sliding. More temperature, it is liquid. More sliding, more entropy. Now, at 100, you know what is happening? Suppose this is 100. Suppose this is 373 Kelvin, 100 degrees Celsius. There is a much sharp rise. Why? This is bigger. Like the length of this is bigger than the length of this. Why? Because here the like solid to liquid is not the change that bigger, but liquid to gas is a huge change. From sliding movement to random. And still, if you are, this is what? The boiling point. This is what? The melting point. And when it turns into gas, it's still increasing. Entropy is not going to stop. Like most of the students have, sometimes they have misconception that when there is this gas, a time will come, it will stop. Why it will stop? You are giving energy. If you are providing continuity, energy and continuity, how the disorder can stop? So like I'm showing this for water, but it could be for anything, like suppose substance X. So at the melting point, it will increase. At the boiling point, there will be sharp rise. For solid increase, for liquid increase, for gas, the change is much more. And the change on the melting would be less. The change on the boiling would be much more. Right? Now, your next thing. So what we studied up till now? We studied that first criteria is what? For gas, the disorder is more than liquid, which is more than for liquid than solid. Now, if physical states are same, then check what? The number of atoms, the entropy is more. But if the physical state, the number of atoms and are same, then check what? Electrons, more disorder. You can check the proton if all the things are same. And at the last, you must know temperature increase, entropy increase, and the the change at boiling point is more than melting point, the sharp rise, because a change into gas is much more than a change into liquid from the solid, right? Now, your next topic is what? Change in entropy, delta S. Change in entropy, right? About change in entropy, there are two topics. There are two topics. Look, calculate delta S and suggest a sign of delta S. We can calculate delta S, we can suggest a sign. Now, listen. If there is a physical or a chemical change, it is always associated with changes in entropy. If products have more entropy, like if the product have more disorders, the disorder is much more, the overall disorder will increase. But if the product have less entropy, if the product have less entropy and reactant have more chaos, the change decrease. So you know what is the formula? To calculate delta S, sum of the entropies of the product minus reactant. Suppose the entropy of the product is 1000, it is 700. So is it increased? 1000 minus 700 increased by how much? 300. But if it is 1000 in reactant, more chaos in reactant, and 700 here, so 700 minus 1000, there is decrease, minus 300 means decrease. The calculations are very, very easy. Now next, sometimes they ask us to suggest, most of the time, there are many, many questions on this thing. So if you are supposed to suggest a sign for any change like this, magnesium is added to HCl. Magnesium is added, magnesium is a solid. Solid is added to aqueous. Less disorder, but much more disorder. The product have more disorder. After the reaction, the disorder is much more. The delta S is positive. Why? Because there is gas, more randomness. Now, potassium chloride dissolve in water. Potassium chloride, it was regularly arranged this way. When you put this in water, the ions become free to move. The disorder, the chaos is more because the ions are now random. They are freely moving. The delta S is positive increase. But if steam is turning into water, it was initially gas. It was initially gas. Now the gas is used up from more chaos to less chaos, negative decrease. So what is your first criteria to suggest the sign? First check the physical state. If gas is in product, the product have more disorder. But if the physical states are same, then count the number of moles. The side with more moles have high entropy. Look this question. Nitrogen plus hydrogen, ammonia, this is gas, this is gas, this is gas, but 4 moles of the gas are making 2 moles of gas. The 4 moles have more chaos, randomness than 2 moles. The disorder decrease. Fewer moles of gases are formed. So what is your first criteria? The physical state, but if they are same, then count the moles of the reactant of the product. If more moles, the delta S is positive. If less moles, the delta S is negative. And how you can calculate delta S? Product minus reactant. Now see, this is a reaction. This is the reaction. Look, These are entropy values. Product minus reactant. Huh? Now, the unit is what? Per mole. But is there 1 mole of Fe used in this equation? This 27 is for 1 Fe. So there are 2, so 2 times. This is for 1 mole, but there are 3 times. So 2 into 27 plus 3 into 2 into 14, product minus 1 Fe2O3 and 3 times this. If I get positive, this shows that the product have more disorder, but if I get negative, the product have less disorder, depends. See this question. Again, it's given there are too many questions like this. Now there are 2 ammonia. So what you are supposed to do? 2 into 193 minus 1 nitrogen, 3 times hydrogen. Now your next topic is delta G, the spontaneity, right? All these notes, listen, all these notes are available on my website, Chemistry by Zeenat, the topical past papers from where I'm taking these questions to solve. You are supposed to do the practice from the past paper. And my next lecture, I think, inshallah, I will finish this chapter, right? Like in 2 chapters, you will be able to do all the question, everything about entropy. So now, before leaving, like, subscribe and share my channel. Okay, Allah Hafiz.